In this video, I'm going to tell you how to create a time machine in 5 easy steps. Some disclaimers may apply.
According to Einstein, time is the fourth dimension in space. So this creates something called space-time, which is like the fabric of the universe. Now, space-time is quite stiff, so it requires colossal masses in order to bend it significantly. But before we can talk about making a time machine, we must first talk about something called a wormhole. Sometimes mass is so concentrated that it can actually tear space-time, creating something called a singularity, or a point of infinite density where space-time seems to come to a dead end.
Singularities are responsible for black holes, in which the singularity is so dense that no normal matter or radiation can escape it. This was expanded on by the Einstein-Rosen bridge, or wormholes, which connects two sheets of spacetime and of the universe.
If you can imagine an apple representing the universe and a worm representing you, normally the fastest way that you can get from the top of the apple to the bottom is to go around it. But the existence of a wormhole changes this. If you cut a hole directly through the center, acting as a wormhole, now the fastest way to get from the top to the bottom is to go directly through.
The wormholes we will be using are traversable wormholes, or ones that you can travel through. But there's an issue. Ordinary mass or energy, whose equivalence can be seen from E equals mc squared, has an attractive gravitational effect that would cause this wormhole contraption to collapse if any mass or energy was passed through it. But what can cancel out the energy? Dark energy, which has a repulsive gravitational effect that can counteract gravity. Using these principles, we could theoretically make a time machine in 5 easy steps. 1. Take spacetime and fold it. 2. Make 2 holes in spacetime and stitch them together to create a wormhole. 3. Bring the wormhole back to Earth. 4. Put a spacecraft through the wormhole with dark energy to counteract the gravitational effect. 5. Set the spacecraft off at close to light speed, assuming we have the technology to, while the other side stays on Earth. It works due to time dilation, which states that the faster an object moves, the slower time passes for it, which was proved in the Hathaway-Keating experiment, in which atomic clocks on board the U.S. Naval Observatory and commercial planes were compared after flight and were nanoseconds off. Theoretically, if the spacecraft travels at close to light speed, 1 year on board the spacecraft could be 1,000 years on Earth. Let's say you and your friend both start in the year 2020. Your friend boards the spacecraft and 1 year passes for her, but you on Earth, 1,000 years passes. But since you guys are connected via the wormhole, you can travel back in time to the year 2021. And now you've time traveled. Thanks for listening.